Good morning friends. In previous lecture we complete capacitance of parallel plate capacitor with a dielectric slab between the plates. These are two conducting plates and in between that we kept a dielectric slab. For this dielectric slab we get the capacitance of these two conducting plates is C is equal to A epsilon 0 divided by D minus T plus T divided by K. In previous lecture we get this equation. Now today we have to see some special cases about this parallel plate capacitor. In this parallel plate capacitor we get a dielectric slab of a thickness T. If we get all the dielectrics in between the plates, that means in these two parallel plate capacitor we fill up the entire space. Of dielectric, then T is equal to D. Then we get the formula for parallel plate capacitors. C is equal to A epsilon naught divided by, now T is equal to D. Therefore we substitute T minus T plus T divided by K. So T minus T get cancelled. We get C is equal to A epsilon naught divided by T divided by K, which is equal to, we get here one formula and we rearrange the term. C is equal to K A epsilon naught divided by T. Now T is equal to T, therefore we get C is equal to K A epsilon naught divided by D. We know that A epsilon naught divided by D is the capacitance C naught. So we get C is equal to K into C naught. That means the capacitance of parallel plate capacitor is increased by K times, and K is the dielectric constant. Here we get a new formula, K is equal to C divided by C naught. K is equal to C divided by C naught. So if we fill the total entire space with dielectric, we get the capacitance of capacitor C is equal to K into C naught. This is the first case. Now in second case, if an N-type dielectric slab having thickness T1, T2 up to Tn connected in series. That means in these two parallel plate capacitor we place n number of dielectric slabs. For example, this slab is divided into n types between these two plates. Suppose this is the one dielectric slab having thickness T1. This is the second dielectric slab having thickness T2. This is the third dielectric slab having thickness T3 up to Tn. Then what is the formula for of these two parallel plate capacitor. So we get the formula C is equal to A epsilon 0 divided by T divided by K. Now we place different types of thickness in between these two parallel plates. So we get C is equal to A epsilon 0 divided by T1 divided by K1, because each dielectric slab has a different dielectric constant. For T1, for first dielectric slab having thickness T1 and its dielectric constant K1. Similarly, for T2 divided by K2 plus Tn divided by Kn plus Tn divided by Kn. So this is the formula for capacitance of that parallel plate capacitor, where these dielectric slabs are connected in a series. सगळ्या ज्या डायलेक्ट्रिक स्लॅब ज्या आहेत त्या आपण काय करतोय एका सिरीज मध्ये कनेक्ट करतोय आणि कनेक्ट केल्यानंतर आपल्याला टोटल कॅपॅसिटन्स ऑफ दॅट प्लेट C is equal to A epsilon 0 divided by T1 K1 plus T2 K2 plus Tn Kn. From this formula we get the total capacitance of that plate. Third specific case, if n capacitor is connected in parallel having surface area A1, A2, A3 up to An, and plate separation by T. Now in between these two plates, if we connect different types of capacitors in parallel having area A1, A2, A3 and separate by a distance D. Then we get the capacitance of this capacitor is by the formula C is equal to epsilon 0 A K divided by D. Right? We get the formula C is equal to general formula C is equal to K A epsilon 0 divided by D. Now distance D is constant and area and dielectric constant is changes. Therefore, we get the formula for this case epsilon 0 divided by D in bracket A1 K1 plus for second capacitor it is A2 K2 plus for if there is a n capacitor we connected, then we get An into Kn. If area of plate A1 A2 up to An is equal to n, then C is equal to we get epsilon 0 A into epsilon 0 divided by n into D into K1 plus K2 plus Kn. If we connected different types of area of capacitor, then we get A1 to N is equal to total quantity is A divided by N. So we substitute this value, we get C is equal to A divided by N epsilon 0 divided by D in bracket K1 plus K2 plus Kn. This is the formula for the capacitance of these two parallel plate capacitor. When we get this formula, when we get a capacitors connected in between them in parallel. या दोन प्लेट मध्ये आपण वेगवेगळे एरिया असलेले कॅपॅसिटर्स ठेवले आणि त्यातून जे कॉम्बिनेशन आहे ते कॉम्बिनेशन कसं केलेलं आहे पॅरलल कॉम्बिनेशन केलेलं आहे त्यावेळेस आपल्याला टोटल कॅपॅसिटन्स व्हॅल्यू जी आहे ती काय मिळते C = A epsilon 0 divided by N into D in bracket K1 plus K2 plus K1. This is the second special case. And third case, if we pick if the conducting plates or parallel plates, conducting plates is filled with conducting slab, with a conducting slab in between them. If we place the conducting slab between these two plates, we know that if we place conducting slab, then the electric constant K is equal to infinity. इथे जर या दोन प्लेटच्या मध्ये आपण कंडक्टिंग स्लॅब ठेवली तर डायइलेक्ट्रिक कॉन्स्टंट फॉर कंडक्टिंग मटेरियल काय असणार आहे इन्फिनाइट असणार आहे सो वी गेट K is equal to infinity and we get the formula for that case C is equal to A epsilon 0 divided by T minus T plus T divided by K, but K is equal to infinity, so we get the formula C is equal to A epsilon naught divided by D minus T. So this is the formula for the capacitance of two parallel plates when we fill in between them the conducting slab. C is equal to A epsilon naught into D minus T. If D minus T into which is equal to C, which is equal to 1 divided by D minus T into C naught. 1 divided by D minus T into C naught. C naught, that means the capacitance without glass slab. So we get C is equal to 1 divided by D minus T into C naught. These are the three special cases where we can connect this parallel plate capacitor with using different types of material. First we fill up total plate with a dielectric, then we place, second case we place different dielectric slab having different thicknesses connected in series. Then we get this formula, and the last case we replace the capacitors and connect them in a parallel combination. Then we get the formula C is equal to epsilon 0 A into K divided by D, which is equal to epsilon 0 divided by D plus A1 K1 up to AN Kn. How much capacitor we connected in parallel, then we have to take their summation in this formula and we get the total value of capacitor. Now next point is this formula is important for the numericals, and in exam also we have to ask 2 mark question on this formula. So next point is energy stored in a capacitor. Energy stored in a capacitor. Energy stored in a capacitor. Suppose this is a parallel plate capacitor is connected with a potential voltage phi. This is the plus, this is the minus, and this is the capacitor C. Now we have to find out the energy of this capacitor. We know that for electrostatic energy we use the letter U. We use the letter U, and we early learned that the energy stored in dielectric or energy stored in material as the types of work done. So for finding the energy, first we have to find out work done by the capacitor. So if the capacitor having a charge Q dash and potential difference phi. The charge can be transferred from the plates by connecting this potential difference. So we get the formula U is equal to, C is equal to capacitance of capacitor, C is equal to Q dash divided by phi. C is equal to Q dash divided by phi. Again phi is equal to Q dash divided by C. So small amount of work done by the charge Q dash is, small amount of work done by the charge Q dash is, work done dW is equal to phi into Q dash. We know that work done is equal to potential voltage multiplied by charge. Now this work done is for a small charge between these plates. If we want to find out the total work done by this plate, so total work done by transferring the charge from these two plates, we have to integrate this equation. So W is equal to integration of dW, lower limit 0, upper limit charge 0 to Q is equal to integration of 0 to Q dW, which is equal to integration of 0 to Q. Now dW is equal to phi into Q dash. So we write here phi into Q dash, and charge, for small charge we write here dQ. 0 to Q phi Q dash into dQ. So we know that phi is equal to, we write here phi is equal equal to Q dash divided by C. P is equal to Q dash divided by C. So we get the equation integration of 0 to Q dash divided by C into dq. P into dq, where is equal to 0 to Q dash divided by C into dq. 1 upon C is constant, so 1 upon C takes outside, 0 to Q into Q dash dq. Therefore W is equal to 1 upon C integration of 0 to Q dash dq, which is equal to 1 upon C. By solving we get Q dash dq, we get Q dash square divided by 2 into Q and lower limit 0. So we get W is equal to 1/2 Q square divided by C minus, here is 0, therefore next term is 0. So we get the work done, W is equal to 1/2 Q square C. This is the work done by the capacitor while transferring the charge. W is equal to 1/2 Q square divided by C. And we know that this work done is stored as the form of potential energy. So we get potential energy of the capacitor. And what is the basic principle or what is the use of capacitor? Capacitor is used to store the energy. So we get the formula energy for energy we use the symbol U. U is equal to W is equal to 1/2 Q square divided by C. This is the one form of equation we get. If we substitute C is equal to Q divided by P. If we substitute the value of Q, so we get Q is equal to C into P. Therefore U is equal to 1/2 C square P square divided by C. 1 C get cancelled. Therefore we get 1/2 C P square. U is equal to 1/2 C. U is equal to 1/2 C P square. Again we substitute C is equal to Q divided by P. We get is equal to 1/2 Q into P. U is equal to 1/2 Q into P. This is the different form of energy we get in this capacitor. Or U is equal to 1/2 Q square divided by C, which is equal to 1/2 C P square is equal to 1/2 Q into P. This formula is important, or this equation is important for the exam. 2 marks question may be asked to derive for this potential energy. Find the potential energy of the capacitor. We get different formulae for the potential energy. U is equal to 1/2 Q square divided by C, which is equal to 1/2 C P square is equal to 1/2 into Q into P. Up to this point, this is the last point of this chapter, electrostatics. So in this chapter we see the different derivations and formulae which is useful for solving the numericals in this chapter. Now we know that for this year 25% syllabus is reduced. So in this topic also the reduced topics are, for example, the reduced topics 8.5 equipotential surface, equipotential surfaces. 8.11 conductors and insulator, bound charges and free charges. And 8.13 handicraft generator and displacement current. Sorry, this is 8.7 and 8.11 is displacement current. These 4 points is reduced from this topic, from this chapter electrostatic for this year only. So these reduced topics need not to study. So now we are going to solve the numericals. For this preparation we have to take formula from starting point of the chapters. So first formula we see the electric field intensity outside the sphere. So electric field intensity outside the charge sphere or hollow conductor, we get E is equal to 1 upon 4 pi epsilon 0 Q divided by R square. This formula is important for solving the numericals. So second point or second equation we see the surface charge density sigma is equal to Q divided by A. Third, next electric field intensity infinite long conductor, we get the formula E is equal to lambda divided by Q 4 pi epsilon 0 into R. Lambda linear surface density, therefore E is equal to lambda divided by Q 4 pi epsilon 0 R. Fourth formula, electric field intensity I write only here E due to charge infinite plane sheet, we get E is equal to sigma divided by twice epsilon 0. Next formula for electrostatic potential energy U is equal to phi multiplied by Q. Or for electrostatic potential phi is equal to U divided by Q. Next formula number 6, work done by the charge, W is equal to 1 upon 4 pi epsilon 0 into Q divided by R. Work done by the charge last W is equal to 1 upon 4 pi epsilon 0 Q divided by R. Next formula number 7. For a torque, W is equal to, we get the formula PE into cos of theta minus cos of theta 0. For the torque, we get P into E cos theta minus cos of theta 0. Next formula for the capacitance of the capacitor, we get C is equal to Q divided by V. C is equal to Q divided by V. This formula we can rewrite as a V is equal to Q divided by C, or Q is equal to C into V. This formula we can write as V is equal to Q divided by C, or Q is equal to C into V. So next formula number 9, in series combination, when capacitance connected in series, for series CS is equal to 1 upon Q divided by CS is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. For a parallel combination, we get capacitance C is equal to C1 plus C2 plus C3. Next formula for the capacitance without dielectric slab, without dielectric slab, C is equal to A epsilon naught divided by D. C is equal to A epsilon naught divided by D. And the last formula for the energy, just now we have to see energy. U is equal to 1 half C V square, which is equal to 1 half Q V. U is equal to 1 half C V square is equal to 1 half Q V, or 1 half Q square divided by 6. This is the formula required for solving the numericals, and these all formulas are important. For each formula we have a derivation, we have proved the derivation, and this derivation may be asked for 3 marks or 2 marks in the exam. Now takes a numerical. Take a screenshot for this all the formulas. First numerical, I write here a parallel plate condenser numericals. First, a parallel plate condenser has an area 2 multiplied by 10 raised to minus 4 meter square, and separation between two plates, is 1 mm. Find its capacity. its capacity. Solution. Now see this numerical, students. A parallel plate condenser has an area 2 multiplied by 10 raised to minus 4 meter square, and the separation between two plates is 1 mm. We have to find out its capacity. This numerical is asked in a board exam for 2 marks. For this 2 marks numerical, we have to write the given data in the numericals. Given data. Condenser has an area, so we have area A is equal to 2 multiplied by 10 raised to minus 4 meter square, and separation between two plates is 1 mm. Separation between two plates means T is equal to 1 mm, which is equal to, we have to convert into meter, so 1 multiplied by 10 raised to minus 3 meter between the two plates, and find its capacity. Means what we have to find? We have to find the capacitance of the capacitor. C is equal to how much? And the permittivity constant epsilon 0 is equal to 8.85 into 10 raised to minus 12 coulomb per Newton square meter square. 8.85 into 10 raised to minus 12 coulomb per Newton meter square. C, we have to find out capacitance. So we know that while solving this numerical, we have to write the answer. If we know that, write down first formula. So we know that the formula C is equal to K A epsilon 0 divided by D. For the A medium, we know that K is equal to 1. Parallel plate condenser has an area 2 into 10 raised to minus 4 meter square. That means K is equal to 1. Therefore, C is equal to A, that means 2 multiplied by 10 raised to minus 4 multiplied by 8.85 into 10 raised to minus 12 divided by D. D means which is equal to T, distance between the two plates. That means thickness of the plates is equal to 1 into 10 raised to minus 3. So C is equal to 2 multiplied by 8.85 into 10 raised to minus 16 into 10 raised to minus 16 divided by 10 raised to minus 3. Now we have to multiply this. So we get C is equal to 17.7 into 10 raised to minus 3 in numerator becomes positive. So we get here 10 raised to minus 13. This minus 3 becomes positive on upper side. So we get here 10 raised to minus 13. So C is equal to 1.77. Rearrange this factor. We get 10 raised to minus 12 farad. So capacitance C is equal to 1.77 into 10 raised to minus 12 farad. Therefore, C is equal to 1.77 into picofarad. We know that 10 raised to minus 12 farad is equal to 1 picofarad. Therefore, we get C is equal to 1.77 picofarad. This is the capacity of this parallel plate condenser. So, for this numerical for board exam is asked for 2 marks. Now, these 2 marks is distributed is like this. For the formula, we have half mark. For the formula, we have half mark. For this solution, mathematical part, solution, we have half mark, and the answer with a proper unit, we have 1 mark. Answer with a proper unit, we have 1 mark. So this is the 2 marks distribution, and each numerical, while solving each numerical, we have to write first formula, then substitute the values in it and write the answer with a proper unit. Then and only then we get the total marks of that numerical. Like this way we have to solve the numericals. So up to this numerical we stop here, and other numericals we see in tomorrow lecture. Thank you.
इथं दाबायचं फक्त ओके म्हणायचं. बंद करायचं लक्षात घ्या बरं मॅडम.